So in the last video, I was talking about taking derivatives of exponential functions when the base is something other than base e. So let's talk about going the other way. What if I want to find an integral or an antiderivative of an exponential function? So there's a rule for this, and that rule says that if we are taking the integral of some base a raised to the u exponent du, to get that integral, I'm going to have 1 over the natural log of whatever the base is times our exponential function a to the u. And then since we are dealing with an indefinite integral here, we always want to make sure that we're putting the plus c. So we'll go through a couple of examples. The first one is pretty basic. So if I want to find the integral of 5 raised to the x power, I'm going to go ahead and just kind of follow this rule here. My antiderivative is going to be 1 over my natural log of my base of 5 times 5 to the x plus c. So what happens if I have something else in that exponent? Well, when we were integrating e to the something, so e to like the 3x, this would be where we'd want to use some u substitution. And that's what I would want to do here as well, because I want to get this into the form of some base just raised to a single exponent, or a single term in my exponent, I should say. So let's pick our u to be this 3x. That means my du is going to be 3 dx. And that's going to tell me that my dx is going to be 1/3 du. And I'll go ahead and do this substitution. So the integral of 2 to the u times 1/3 du. I'll pull that 1/3 out as a constant. And now I have something that kind of matches what my rule says. I've got just a 2 to the u exponent. So in order to take the antiderivative here, I'm going to pull down that 1/3 and I'll follow the rule. So that's going to give me 1 over the natural log of the base of 2 times 2 to the u plus c. And then I don't want to forget to not only substitute back in for u, but I am going to clean this up a little bit. And we are going to be condensing a little bit using natural log rules. So I'm going to rewrite this as 1 over 3 ln of 2. And then I'm going to go ahead and substitute back in my u, so 2 to the 3x plus c. And I'm going to bring this exponent up onto the 2. So using those condensing rules, so that's going to give me an ln of 2 raised to the 3rd power times 2 to the 3x plus c. And I'm just going to take one more step to simplify that to be 1 over ln of 8. So 1 over ln of 8 times 2 to the 3x power plus c is my antiderivative here. Okay, so we'll do one more example. This one's got something with our base of 4 in this case, which you're probably thinking that we're definitely going to want to use substitution here. So if we think about if we're setting u equal to our exponent, our derivative is definitely going to have something to do with that x. So I'll let my u be my exponent of negative x squared. My derivative du would be negative 2x dx. And that means that my dx is going to be du divided by negative 2x. So using that substitution, that's going to be x times 4 to the u times du divided by negative 2x, which means my x's are going to cancel out here. That negative 1/2 I'm going to pull out as a constant. And I'm left with 4 to the u du. And now I can just use my integration rule here. So negative 1/2 times 1 over the natural log of 4 times 4 to the u plus c. And I'm going to do something pretty similar to what I did in the last problem. I'm going to go ahead and multiply those. I'm going to go ahead and substitute back in my u. So it's going to be negative 1 over 2 ln of 4 times 4 to the negative x squared plus c. Bring that up as an exponent. So your denominator is really going to be the natural log of 4 squared. So in one more step, I'll just simplify that to be negative 1 over the natural log of 16 times 4 to the negative x squared, and then plus c. And that's the basics of integrating an exponential function. So I'll have you guys do some practice. Let me know if you have any questions.